Welcome back, 6th grade, to lesson 76. Yeah, we skipped 75, but we'll get back to it. Something called complex fractions. Fractions that contain a fraction. That's a complex fraction. The fraction can be in both numerator and denominator. It could be a fraction on top of a whole number on top of a fraction. Doesn't really matter. All right? Complex fractions, and the thing you really have to understand here is that complex fractions are never in simplest terms. So this lesson is all about how to make a complex fraction simple. And there's basically two ways to do it. There's the book's way, and then there's a way I came up with. And it won't hurt my feelings if you use the book's way, but I think you might find my way might be a little bit simpler. All right? So, here's an example of a complex fraction. 3/5 over 2/3. All right? When there's a fraction over a fraction, you'll always notice that the fraction bar, there's one fraction bar that's longer than the other ones. All right? And that bar is the divided by. That's your signpost, so to speak. So this says 3/5 divided by 2/3. It's just another way to write a division problem. We've been writing division problems like that all year. 8 over 2 is 8 divided by 2, right? So now we've just got a fraction divided by a fraction, and we're showing it as this thing called a complex fraction. So your book would tell you that what we need to do is make the denominator of the complex fraction equal to 1, because then we don't need it anymore. Something divided by 1 just kind of goes away. And you can make anything into 1 if you multiply it times its reciprocal. Flip it over. Which is basically what we do when we divide fractions anyway. I mean, this says 3/5 divided by, that's that big bar there, 2/3, right? And if you're dividing a fraction, we know that what you're really doing is inverting the second fraction and multiplying. So 3/5 divided by 2/3 is the same as 3/5 times, flip it, 3 over 2. Top times the top, bottom times the bottom, and you get 9/10. All right, and that's how your book does it. It basically says take whatever's on the bottom, flip it over, and multiply it times what's on the top. That works. On the other hand, I've come up with this thing called outer, upper, inner, under. Outer, upper, inner, under. Kind of catchy, easy to remember. And it simply says that when you've got a complex fraction, they're already stacked up like that. You don't need to rewrite them like that, all right? And I found that people often have problems. Which one do I flip? Do I flip the first one? Do I flip the second one? Do I flip them both? Well, outer, upper, inner, under, you don't deal with that. You look at it as a complex fraction, and you've got two numbers that are your outer numbers, the top and bottom ones, 3 and 3, right? And so you remember outer, upper. We're multiplying. So we're going to multiply the outer numbers. 3 times 3 becomes the upper number in the answer. Outer, upper. 3 times 3, 9, upper. Inner, the two numbers that are inside, get multiplied, and they go under. Outer, upper, inner, under. There's your answer. It's the same pattern as this, except you don't have to rewrite it and flip things. You just take advantage of going outer and inner, multiplying, and putting the outer one in the upper part of the answer and the inner one on the under part of the answer. Very simple, right? So if you see something like this, all right, a fraction divided by a whole number. Well, remember this is saying 1/4 divided by 6, all right? And we can write 6 as a fraction, 6 over 1. And the book tells us then to take 6 over 1, flip it, and multiply it times the top. Top times the top, bottom times the bottom, 1 times 1, bottom 1/24. We flip the denominator of, and the reciprocal becomes the multiplying problem there. Now if this were outer, upper, inner, under, 1/4 divided by 6, we again make 6 into a fraction, right? 6 over 1. And I'm showing that with little dots here, all right? But, all right, 6 over 1. And so now I've got outer, 1 times 1 goes upper, inner, 4 times 6 goes under, 1/24. You're done. Okay? Outer, upper, inner, under. Or you can flip things. That's up to you. All right? Let's try some more. Suppose you've got a mixed number in a fraction. All right? Well, that's not simplest terms. You can't have fractions in fractions. That's too complicated. All right? So the very simple thing is you got to take the mixed number and change it to an improper fraction. 2 times 3 plus 1. 7 halves. And 20 you have to make into an improper fraction. It's a whole number. So you just make it into an improper fraction by putting it on top of 1. So you wind up with this complex fraction, 7 halves over 20 over 1. The book would tell you flip the bottom one and multiply times the top. 7 halves times 1 over 20. Top times the top, bottom times the bottom. All right? Or, once it's written like this, you can take advantage of outer, upper, inner, under. Outer, 7 times 1, upper, inner, 2 times 20, 40 goes under, you're done. As always, and with any time you've got an answer to a fractional type problem, it better be in simplest terms. Alright? We can put the mixed number on the bottom. Doesn't matter. 15 over 7 1/3. Alright? Well, I mean, you can look at this and go, 15 divided by 7 is a little bit more than 2, so your answer should be a little bit more than 2. So I change 15 into an improper fraction, 15 over 1. I change 7 1/3 into an improper fraction, 3 times 7 plus 1, 22 over 3. And now I've got this nice complex fraction. I can flip the denominator and multiply it times the numerator, top times the top, bottom times the bottom. Gives me an improper fraction that I put in simplest terms. 45 over 22 goes 2 whole times with 1 left over. Or I can use outer, upper, inner, under once I've got it written as a complex fraction. 15 times 3, 45, inner, 1 times 22, under, and again, you get the same answer. Right? Let's look at percentages, all right? We've changed percents into fractions very easily by putting whatever the percent is on top of 100, right? Because that's what it means. Per, by, divided by line there, and cent, the Latin for 100. So 83 1/3% written as a fraction, we would start off by taking the percentage, 83 1/3, and putting it on top of 100 to make a fraction out of it. But this is a fraction in a fraction, so we've got to simplify it. Big deal. We simply change 83 1/3 into an improper fraction. 3 times 83 plus 1 is 250 over 3. And we change 100 into an improper fraction by sticking it on top of 1. And then outer, 250 times 1, upper, inner, 3 times 300, under, 250 over 300. We put that in simplest terms, and you get 5/6 is 83 1/3% as a fraction. Let's try it again. Change 8 1/2 to a fraction. All right, I start off by 8 1/2%. I just stick 8 1/2 on top of fraction bar 100, 8 1/2%. But now I've got a fraction and a fraction, so I change 8 1/2 to an improper fraction. 2 times 8 plus 1, 17 over 2. Change 100 to an improper fraction, 100 over 1. Outer, 17 times 1. Upper, inner, 2 times 100, 200, 17 over 200. You're done. In fact, that's as hard as it gets. So what you need to do is practice this, all right? So you get some practice in lesson 76 by doing A to F and 8 to 13. And you should probably show your work on this. All right? See you later.